Hey guys, I'm Nick and welcome back to another tutorial. Today we are creating this kind of attraction effect with dynamic colliders inside. So we kind of create a countdown. Only now I realize that it is sort of a reverse countdown. So this one is inspired by designersvane. He did these gummy worms in Cinema 4D, but I wanted to check how we can utilize Vellum claws and also make the collider dynamic. I really love that negative space here. So yeah, let's get back to Houdini and let's set up everything that we need. So of course, start with the geo. Do we need cameras and lights now? I don't think so. But yeah, so in the geo, we start with the grid, which will be sort of our piece of fabric. And here, I want to set the size to be, something like 5. So we go, no, rows should be 5 and columns should be 5. No, actually columns 10, rows 5, something like that, I think. Yeah, and then we drop a circle. We should have a pretty big circle, which is orientation set to ZX. So it lays down, press 2 on keyboard, and it will give me a top view. So yeah, if our grid is 10 by 5, I assume that we will need a pretty big circle. So something like this, I would say. And maybe 7, 8, actually maybe 5, 6. Yeah, let's stay with the 6 grids. And now copy to points, and I said 6 grids because we are copying the grids to points, and we will have these grids copied like that. So the only thing we need is to rotate our grids in XY plane, and if we don't want to rotate them but still want to kind of align them with the normals, what we can do is add this poly frame, and here in the tangent name we set it to be N, but also remove the normals, and polyframe will add its own normals. So now we can get our grid to be ZX again, make our circle a bit bigger, or also we now what will be if we rotate our grids. So oh yeah, I like this one. So -90 for the grids, ZX plane, and yeah, now we can make our circle a bit smaller. So we have that base setup, what I want to do now is Vellum configure class, which will be pretty default. We can leave it as it is right now for the moment. Here we drop 2 nulls as we usually do. One will be out geo, second one will be out con for our dop network. But yeah, the class is very basic setup here, and there's nothing super heavy or something extra. But we forgot 2 things. One is add UVs to our grids, right? And second one is about rendering. But you know what? Let's create the DOPNet for the moment, and we will get back to these materials a bit later. So now we will need our text. The main thing was I was like, all right, let's do the VDB morphing, but I wasn't sure how to do it in a right way to morph multiple objects, because what I saw, what I found, and what I knew, it all was based on morphing just one object to another object and not morphing like more than 2 objects. So that's why we are actually creating multiple font objects, and we'll be just kind of cross-scaling between them. To make this tutorial faster, let me just add a few text nodes like font 1, poly, extrude, and of course we will need transform. So font goes into our extrude and our extrude goes into transform. Let's get back to the font 1. In this tutorial I will be going from 3 to 1, maybe 0. But yeah, basically we start with a 3. What we need to do here is of course make it bigger, because we have our copy to points. Look how big it is actually. I think we can go with a font size 10. No, let's actually rotate it so it's laying down flat. And all right, let's say 5 should be something. And in the poly extrude, we wanna extrude it like 2, I think. image should be minus 90. And in transform, then in poly extrude, of course, we want to output back. Yeah, I don't know, maybe I also want it to be kind of centered. So if I go poly extrude and again copy this distance parameter, go back to the transform, and in the translate I can paste relative references. What it will do nothing because we have this 0 here, but yeah, right now you can see that we got our font translated by 2 because 2 is how much we extruded it. But if we subdivide it by 2 and also make it negative, we should be, yeah, centered, right? And now if we change this distance here, you know, it's extruding in both directions. So we need a bit more of these. So 3, 2, 1. And you can see that for this transform 3, which is like copying all of these, and copying is just like holding the Alt, I assume. In my case, it's Option on Mac. So here you can see that this transform actually inherits the right poly extrude. It does not keep the reference to this poly extrude 1. So that's really smart thing from Houdini. And yeah, basically we have our 3, 2, 1. Let's merge them all into this merge node and now create VDB from polygons. Oh, of course we want 2 and 1. And for the font, by the way, I suggest you get something bold. So Arial, in my case, where it was Arial bold. Yeah, perfect. This is how it should actually look like. And yeah, we go VDB from polygons, and VDB reshape SDF is also what we need. So we reshape SDF. Just, yeah, make them a bit more bubbly, wobbly, whatever. And let's add a null out VDB collider. All right, but how we actually animate these numbers? So the main thing is that, so we need to scale up the next number a bit earlier then we scale down the current number. So let's go here in the transform tabs of our 2 and 1. Let me just name them. 3, okay. 3, 2, 1. All right, cool. So these two should be 0 because they are not visible right now. They don't influence our simulation in any way. So here we have our transform. Of course, we will need some frames for our claws to kind of get to this initial shape. So let's say we will give that clause 60 frames to wrap around this number 3. So at frame 60, let's add a keyframe and set the uniform scale of the number 3 to 1, as it is by default. And at the frame 90, I want it to be 0. Now we want to set the scale of our number 2 to actually start animating scaling up earlier. So at frame 45, let's set the keyframe of number 2 as uniform scale equals to 0, as it is right now. And at the frame 80, let's set it to be 1. So now, if we do this merge, actually here VDB reshape SDF, you can see that we are starting to animate the number 2 and it grows like this. So you can see that there's very little boundary, very little, you know, the cross section, or I mean the morphing, the actual morphing that is here. So it goes like this: 2, 3, 2, 3, 2 again. So yeah, and this is how you want to morph between all of them. And then we can do same thing with our 2 and 1, transition from 2 to 1. You can see that we have our number 3 for 60 frames. So I assume at 150, we wanna, actually at 140, we want to scale down our number 2 from 1 to 0, but also we want to scale up our 1 a bit earlier. So at 130, I assume, or no, 125, we scale our number 1 from 0 to 1 at frame around 160, 164, 165. So yep, sounds good. And here you can see the cross section, that crossfade actually between 2 and 1. So yeah, that's our collider setup, but there will be more things I want to share with you in the DOP network. So yep, drop the DOP and let's go inside and set up our Vellum solver, Vellum object, Vellum. Oh, nope. We are going back somehow. Let me just add it once more. Vellum object goes here. Nope. And goes into the left input, and Vellum source is what we also need here. Nice. Vellum source, Vellum object. Yeah, subpass. Of course we need a subpass. Let me just boom. So obj geo out. Geo goes into the subpass. Constraint subpass should have our outcon. Yep, we have our grids here. So we need to set up a few colliders here. Let's drop a merge. Here it is. All right, so for this effect, I want to add our collider, which is animated volume. Then I want to sandwich these fabrics, these cloth strands or cloth grids between two planes, actually. So what we can do is add a ground plane, add another ground plane, and here rotate 180. Oh, nope, not this one, by Z. So now we will have two ground planes that can go here, ground plane above, ground plane above. All right, two ground planes. Looks awful because they all share the same y-axis position. So maybe this ground plane, we can move it a bit up. Both of these ground planes, just to make it easier for the simulation, for that wrap effect, bounce forward, friction set to 0.05, dynamic friction scale, I think it was 0.1. So we don't want any like much friction here, right? So now we wanna probably hide those ground planes, because otherwise we won't be able to see anything. But if we add gravity and if we add wind, just to test out if our setup works, yeah, and it just bounces like something is wrong. Let's make our ground plane 2, which is the top one. Let's make it higher so there's a bit more room. Yeah, there is a bit more room. Yeah, now it works fine. Of course, we can do it right now. We will need more rows and columns. Let's try. So the ratio is 1 to 2. So actually we can go like 30 columns, 15 rows, maybe something like that. Of course, we will be using subdivision, like Vellum post-process subdivision afterwards, but yeah, let's make the pop wind amplitude like 3 or something. Yeah, cool, I like that. So now the fun part begin. Let's add our static object, and subpass should be out VDB collider. Create active object, use object transform, use deforming geometry should all be checked. In the collision, we should use volume collisions. In the mode should be volume sample. Division method should be by size, and proxy volume should be out VDB collider. Now, if this goes into the merge, if you did everything correct, you will see your collider here. But all the colliders should be on the left side and Vellum solver should be on the right side of the merge. So static object goes here. They all kind of should go one by one. So ground plane 2, ground plane 1, static object, and then our Vellum solver in the merge. You can see here, it's all kind of beautiful. You don't want it to be like crisscrossed like this. Or you can also set the relationship to be, oh no, actually a factor relationship should be mutual. Then it's like, it doesn't matter how you plug them in. But I like to keep these all clean, and yeah, left inputs affect right inputs. So now if I select display geometry, uncheck that display geometry, and actually check collision guide here in the RBD solver in the collisions tab, you now can see the actual collider that we have here. So now if we play it, nothing actually will happen because there is no force that actually attracts our cloth strands to this number 3. So we of course need our pop attract here. So the objects here are pretty big, so I assume we wanna try something around 50 for our fourth scale. Let's just simulate a few frames. Yeah, it might be a bit too much. So reversal distance, no, actually, yeah, let's go with the force scale at 20. Max distance should be, I don't know, should we modify it and set it to be 20? Reversal distance 0, peak force distance, I would like to set it to 1. And yeah, I think we should be good. No, it's too slow. You know what, let's maybe keyframe this, start with 50, and at the frame 30, let's make it 20. So let's simulate a few frames and see what we got with these settings. I ended up setting the force scale to be 100, and then at frame 30 dropping to 20. But there's also one thing that we need to add is that pop win, and basically we're adding it because of the air resistance, but also we can set the amplitude to be something like 3. We want to set it to something bigger, and let's select 180 frames and simulate that. Now we see that as I added wind and added air resistance, you can actually see that 25, that traction force scale at 25 is not enough. So we now should start at 200, and I assume at the frame 30 we can leave it at 50, and let's just check how it looks. Here you can see that it kinda works good, but it's very jittery, and this means that we are using too much of that force here. So let's remove 50 and use 30 instead. Yeah, that definitely 30 works better. We still have that jittering, but we will talk about how to solve it a bit later. And yeah, maybe I want to start with 150, not 200, because it kinda makes them too crumbled here. If I play it live, you can see. Also, what I want to add here is make these grids a bit wider, like this. So yeah, for the rows and columns, we'll talk about it later, we can adjust the rows to get those squares, because squares are best to simulate it. And for the dop network, again, let's play it and see what we got. Yeah, I definitely like this result. Just for a quick preview, our dop network, we wanna remove this shift 8 sign like this. I wanna remove that from object and just use the Vellum object here and add Vellum post process, plug a .NET into the Vellum post process, and now we can apply, I don't know, maybe 2 subdivisions, and already it looks much better. And extrude by thickness scale, I want to keep that at 0.1 maybe. Spatial blur at, oh no, at 0.2. Yeah, now it looks much better. And of course this one needs a camera with a pretty big focal distance. So now I select the cam 1, let's adjust it so we at least see something. 0 0, oh no, 0 7 0 minus 19 0. For the render, for the view, I want to render it 1080 by 920. And here, focal length, I want to set it to be 125. This makes it more kind of straight without the distortion. So it's easier to see the numbers here. But yeah, I think this looks pretty good. We maybe it will be cool to add a bit of damping ratio here. So for this one, actually you don't want them to be that bendy, so stiffness is 0.001 and damping ratio for stiffness 0.5 and damping ratio for bend maybe at a 0.03. It will make it, the damping ratio essentially will help us to kind of wrap our numbers a bit better. So, and this all is on Vellum solver being at substeps being at 1. So this is really crazy that it actually works without so many artifacts. But yeah, we will definitely need to add more substeps. I already see it. For example, here So if we go back to Geo, now you will see here it was the stretching there that we will need to get rid of. But still, yeah, it doesn't look too bad. I think it's still pretty cool. You know what I'm starting to think about? If we actually need to kind of make our ground planes, which are kind of our sandwiches, if we wanna make it a bit lower that second ground plane. So let's try 0.6 maybe, and again just turn off this display proxy geometry and let's simulate a few frames and see. And now it's looking better. Yeah, we have the better shape here. The only thing I might want to add is just as an experiment, you know, add a bit more subdivisions to my grids here. So rows at 30 and columns at kind of 42, I think. Yeah, and let's see what we get now, because the more of these subdivisions, the more the rows and columns we have, the more kind of detail we will have, but also it will require more substeps and make our simulation slower. So it's always that decision you want to make. So at frame 130 it looks like this, but let's enable the Vellum pose process, and yes, I like this much more. It's hard to scroll with a subdivision turned on, but basically it goes like 3, then 2, and you can see that with the 3 we have this artifact in here. So how to get rid of it? With a Vellum solver here, in my project I set the velocity damping to be 0.2, substeps 3, constraint durations 300, collision passes 100, post collision passes 6, polish passes 30, and layer shock left at 4. And this gave me pretty decent results. I cannot say it was ideal, but it was better than like with the substeps being at 1. So now you can see that collision is working better, but now because of all of these planes it's the same y-axis, look at how they actually collide with each other and lose the momentum. And yeah, what we can do now is make them kind of in a stepped fashion, and then we can also make them wider. So why don't we go and set the size to be a bit wider, so 10 by 10, just for example. You can see that they are colliding now. What we can do is, for the circle, it's essentially a set of points, right? 1, 2, 3, 4, 5, 6 points. Let's, after this polyframe, delete everything but keep the points so we can work with them. Delete everything, but keep the points, right? So we have the points. Every point has its number, 0, 1, 2, 3, 4, 5. What I want to do is add a transform, nope, not transform actually, wrangle, attribute wrangle. What I can do now is set the position at y-axis to be equal to something connected with these pt nums with 0, 1, 2, 3, 4, 5. So at p dot y, so position at y-axis, is equal to at pt num, and you can see that they already went up. And if we now copy to points, visualize this copy to points, you can see that obviously they go like a ladder. Of course, our ground planes here are in the range of 0 and 0.6. So what we can do is our attribute wrangle should be pt num divided by 10, which will make them, or at least should make them, lower, but in still that ladder fashion. But I wanna check if this works. Let's go to the geometry spreadsheet. Oh no, it does not work. Why? Let's go, and this pt num is int. Maybe we want to go with the float pt num. Yeah, now it works because it's int. If you divide 1 to 10 and you are still in the integer format, it will be 0. But if you are in the float format, it will be 0.1. So what we have now is this ladder that actually works. And yeah, geometry spreadsheet, it goes to 0.5 and our grid is at 0.6. The top grid is at 0.6 here. So everything should work fine now. Yeah, let's simulate and see what we get. Then the setup needed a few adjustments. One of them being this puppet rate, which I start at 150 and then it goes to the 45, not 30 at frame 30. And also I added a few subdivisions. Rows and columns are now 50 by 50 and Vellum clause as 0.0001 at advanced stiffness. These adjustments took me some time because it's always a sort of an back and forth, so I did that off camera. But yeah, essentially we get this result. Let me look that through the camera. There's no much jittering left, especially if we will be using Vellum post process with a spatial blur. Yeah, but this looks pretty beautiful to me, and the shape is well defined, and of course a bit too slow to simulate. Yeah, let's maybe simulate till the frame 120 to look at how beautiful these are. Yes, it's frame 120. It looks even better. So yeah. This is the setup here. You might want to retime it, right? So retime goes here. Then what I think we should add, is file cache, and you cached out. No, you actually cached it out here before actual Vellum post process and retime. I won't be doing it right now because it's not necessary. But yeah, you know what? We forgot one crucial thing here. So material goes here, and we will need to resimulate it. But the main thing for this material is that we want to create the attribute, the integer attribute called material, which should be equal to the pt_num. And here in our material, we will need to specify one of our materials. So matnet material network should be added here. Now let's go inside the material, and rs material goes here. And now a redshift material, the one that kind of outputs everything. And now rs shader switch is what we will be using. Now rs user data is rs integer user data is what we can grab, and this will be material. In the attribute name we should specify that it will be material. It's what we just created. And now we go and create 6 materials like this, and they all go into, I don't know, yay, cool, it works. Look at that. Yeah. And let's just set the colors to something very default, but it's just for us to better see if it all works. Cool. And out color goes to the surface, and this is our fabrics material. Now we go back to the geo in the redshift obj, in the renderer, we go select our matnet and our fabrics material. Yeah, actually then we don't need to specify material here, so it's cool. Just make sure you have this integer attribute that is called material, and it's equal to pt_num, so it's different for each of these. Now if we go to the .NET and simulate, for now let's simulate just 60 frames, and let's bypass the file cache for now, or you can save to disk. Let's add the Vellum post process. Do we have the normals? I assumed that Vellum post process add normals, but let's just check. If I add normals, something changes? Nope, nothing changes. So I assume that Vellum post process some sort of magically applies the normals. Just want to check if I add the new pane tab, set it to be a redshift render view, what I will get. Oh, look, it works. Great. So our slide dome, of course. Light should be in our resources. Nope. Oh, yeah, it's in the root folder. Duration set to 0. Light, I don't know if I like the direction of the light, so maybe rotate it. -15, 30, I don't know. 5, just randomly picking the numbers, really. But yeah, I think this looks pretty cool. Oh, and of course 0, 0, and maybe 10 is how we want it. Yeah, maybe 14, 12. Yeah, 12 is good, I think. One thing we want to remove is the background, environment background, and yeah, just render it out with the alpha. For the materials, I was using just sort of a fabric preset, not the preset, but fabric pre-BR material. You can probably find the textures in here in the rest folder. Fabric normal and fabric roughness, those are free PBR materials. You can use them in commercial and personal projects. But yeah, for the geo, just then use retime, and I think that's it actually. And yeah, I think this tutorial is already a bit too long for majority of you guys, but please let me know if you like these tutorials, like live tutorials, more than walkthroughs, breakdowns, I don't know how to call them. Your opinion is very much appreciated. I can do these tutorials or I can do breakdowns. It's all up to you. What do you like? What do you want? So if you have any ideas, questions, whatever, please let me know on Patreon, in Discord, Patreon comments, Patreon messages, whatever. But I will be back very soon with another tutorial for you guys. Thanks so much for supporting me. It's all possible only because of you guys. See you soon. Bye.